We'll see if it works. Okay, so lesson 3.3. Solving a system of equations by graphing. Thoughts on where to start? What are we going to need to do? Gabe?
Get y alone.
Yeah. If we're going to graph these, negative 3x plus 2y equals 8, how do I graph that? We have to get y by itself, right? This is an important thing. You guys have to know how to get y by itself. So we're going to get y by itself. What's our plan here?
Minus 2y from both sides.
I wouldn't.
Oh, you want to move the...
Divide.
Okay, if we're wanting to get the 2y by itself here,
Add 3x. Oh.
if I already have the 2y here, to move the negative 3x, how do we move a negative 3x over? We're going to add 3x. If I add 3x on one side, we're going to add 3x on the other side. So 3x's cancel, right? 2y equals, what is 8 plus 3x?
3x plus
Okay, 8 plus 3x, 3x plus 8, not 11x, right? So we are looking at a 3x plus 8. Am I done? Is y by itself? No. What else do I have to do?
Divide by 2.
Divide by 2, right? If it's 2 times y, we're going to divide by 2. What is it I'm dividing by 2? Everything, right? So we're dividing by 2. 2y divided by 2 becomes y. 3x over 2. I'm going to leave us 3x over 2 because I'm going to graph this. I heard someone say 1.5. I'm not going to disagree. It is 1.5. But when I have to graph this, I'd rather have the fraction for this one. Plus 8 divided by 2 is 4. Okay, are we ready to graph that? Yeah, we're ready to graph that. As we graph that, remember, what form is this in?
Y equals mx plus b.
Y equals mx plus b. That is my question exactly, because it changed color on it for me this morning. What did I do?
Yes, I think
Oh, maybe you have to untap the red, because it looks like they're both. It looked like they were both tapped. Because you see how they're both still have the circle.
Yeah, but it was doing that for me this morning. The red is like locked on somehow. This is annoying. I like to change colors. You guys know that by now, right?
See, maybe they'll get one for you like Rogers, where like all the pens have their own separate colors.
Okay, somehow.
Maybe it's just because it's your secondary pen.
Yeah, this morning I was able to change colors. Okay, so I've done something to goof it up, but whatever. Okay, all I was trying to do there. Again, this is my experiment group today, right? Part of the experiment is, can I record a video this long and will I be able to upload it?
Right.
You know, I don't know. So, anyways, y equals mx plus b. What do we know? What do we graph first here? What do we know first?
Base?
We don't call it base, but I'm assuming you mean the b, right?
Yeah.
What does b stand for?
y-intercept.
The y-intercept, right? And I'm going to try. Remember, which axis is which? We've got x-axis and y-axis, right? It's labeled for you. So I'm not asking you to remember. It's labeled. And so when we graph this, okay, a y-intercept of 4 means we're going to go up 4. Now, what else do I do?
Find slope with x over 3x over 2.
Okay, so slope is the 3 over 2. What's our phrase for slope?
Rise of Run.
Rise over run. Does that sound familiar? Okay. Again, this is important. I hope you guys are really with me here, and you've got to stick this into your brain, how to graph like this. So from the point I just made, I'm going to rise 3, which means up 3, run 2. I'm going to go which direction?
Right.
Right 2. Now, I can barely go up 3 over 2 again. What else can I do when I'm graphing?
The opposite.
We can reverse this, yes? So instead of going up 3, right 2, I can also go down 3, left 2, down 3, left 2, down 3, left 2, down 3, left 2. Yeah, I'm kind of a crazy dot person today. There's a reason I'm going crazy with my dots, though. Okay? Technically, I'm not saying you have to make all these dots. You're not going to be counted wrong for not making all these dots. Now, these dots connect and form a line. The straightness of this line is important. I, of course, am doing this on the whiteboard, which makes it not very easy, but that's the reason I went crazy with my dots, is because if I have all those dots in there, I don't have to be quite as concerned about how straight my line was or was not. Okay, now what? Now we've got to, same thing with the other one, right? So this time, x plus 2y equals negative 8. How do I graph?
Take away x.
Okay.
Minus x for both sides.
Again, we're trying to get to this y equals mx plus b form, yes? So if I've got a y here, start by moving the other term away. So if it's a positive x, I'm going to subtract x. What I do on one side, whoops, I do on the other side. I don't have an undo button here, do I? And I can't get it to make a... Okay, that was x plus 2y equals negative 8. Subtracting x. Now, I goofed up. I don't know if anyone caught it. I just goofed up what I was writing. If I subtract x on the left, when I say subtract x on the right, what do I mean? On the right side of the equal sign, yes? I subtracted from the 2y. And those are both on the left side. When I say left and right, I mean left side of the equal sign, right side of the equal sign. So, lesson from my mistake. Okay, x's cancel. 2y equals, what's negative 8 minus x?
Negative x minus
Okay. Notice all he did is reorder the pieces, so the x is first. It's a negative 8 and a negative x. So I keep the negatives or the minuses with them. Is y by itself?
divide by 2.
Gotta divide by 2. And remember, I'm going to divide everybody by 2. 2y divided by 2. It's y. Negative x divided by 2.
Negative x divided by 2.
Okay. What's the invisible number in front of x? 1. And it's not that you have to write it in on that previous, but you need to realize, oh, that's a negative 1x over 2. So I'm actually going to write this as negative 1/2 x, if you will. Okay. Minus 8 divided by 2 is 4. Okay. Now do I have y equals mx plus b form?
Yeah.
I certainly do. Okay. What do I do?
Plug in your y-intercept.
Okay, y-intercept. My y-intercept in this case is
Negative 4.
negative 4. Where do I put a y-intercept? On the
Y line.
y-axis. So I'm going to go 4 down. How do I graph from there?
Rise of a run.
Okay. My phrase is rise of a run. And what's my slope?
-1.
Okay, notice -1/2. We have options here. We tend to, and I'm perfectly fine with this is how I like it. When I say -1/2, I tend to put the negative on top. So -1 over +2. Or what's the other option? You can have a +1 or a -2. It doesn't matter. Okay, so if I go from this point, rise -1, run 2, that means I'm going to go where? Down 1, right 2. Down 1, right 2. Down 1, right 2. So on and so forth. And what else can I do? I can,
Up.
yeah, reverse it here. We're going to go up and over. And that's required in this problem. So I'm going to go up 1, over 2. Up 1, over 2. Up 1, over 2. Up 1, over 2. Okay. You got your line? Connect the points. Am I done?
I'm gonna say no.
Wait. You still got a shade, right? Or is that part of the equation?
No shading. There's no less than or greater than signs. Save that for tomorrow.
Oh my gosh.
Kavera?
Solution, just for the ones.
Yeah. So it's kind of we can answer either way. Are we done? We're technically done. However, if you move on from this problem right now, you don't get full credit because you've never stated what your answer is. Yeah, what is my solution here? What are you thinking, Kogan?
-4, -2.
I think he's right. You guys see that? Where is my solution? It's where the two lines intersect. And so if you look right here, did your two lines intersect on one of your dots?
Yeah.
And that's the whole reason I go dot crazy in this lesson. Is because does it matter if one of my lines wasn't quite straight, especially since I'm up here drawing on the whiteboard? Yeah, it didn't matter if I, went a little crooked with one of my lines. As long as my dots end up matching up, that's what I'm looking for. So that ordered pair from the origin is 4 left, 2 down, for an answer of -4, -2. So you don't want to go to all that hard work and not have an answer to put down, right? Okay. Questions on that? You did that back in Algebra 1. I know you did. I'm not going to say I know you remember it, though. Okay, so, again, we're looking for where the equations cross. The more dots you make, the more you know you're going to be able to find out where they cross. There's only one option for when lines won't cross today. Okay, it's a no solution if the lines don't cross, but the lines have to be parallel. Okay, so if those lines are parallel, then that's the one time you get to put no solution because they don't cross. Okay, otherwise, if they are angling at all, they're going to eventually meet. Now, at what we're doing at this level, your dots, I believe, should always meet at a point. If you do all of your rise of a run, you should eventually meet. So you shouldn't be having to say like, oh, well, I think I'm meeting in the middle of that box. I'm going to say, 2.5 and -4.5. No, they should meet exactly at a point. Okay? Okay. Try the next one. Now, I think in order to do this, let's see. I'm still recording, but I lose the print, but it's in the recording, so. Okay, let's try this and see what happens. Okay, are you starting without me? Not good point, that's a good thing. Okay, x minus 2y equals 4. What are you doing to get yourself ready to graph that? Trying to get y by itself. How do we get, so we have to move the x away, right? How do we move this positive x over to the other side? We're going to subtract x. If we subtract x on the left, subtract x on the right. X minus x will cancel, and now I have negative 2y. What is 4 minus x? Not exactly. There we go. There's the right combo. Okay, so negative x, yes. And then since it's a positive 4, we want to say plus 4. Okay, good. Am I done? Have I solved for y? No. What are we going to do? Divide by negative 2. And notice I'm dividing every single term by negative 2. So, negative 2's cancel. Okay, do you know what to do with this one this time? Negative x divided by negative 2. Okay, so a negative divided by a negative is going to make it a positive. What's in front of the x is an invisible 1. So I'm going to think of this as 1/2 x. Plus 4 divided by negative 2. What's 4 divided by negative 2? Minus 2. Okay. Do I need to write in y equals mx plus b under there? You got it this time. Where's the first point I'm going to put on my graph? Okay. Negative 2 where?
On the y-axis.
On the y-axis. Okay. And this is a mistake I was seen on the test. A y-intercept of negative 2, and people would put it on the x-axis. Nope. Y-intercept goes up or down. Negative 2 is going down 2. Then what?
Up 1 over 2.
Up 1 over 2, he says. Yes? It's a slope of 1/2. So I'm going to rise 1, run 2. Up 1 over 2, up 1 over 2, up 1, right 2. And then what should we do since we don't know where the other line's going to be?
The opposite.
Yeah, the opposite. Down 1, left 2, down 1, left 2, down 1, left 2. And in all honesty, can you always come back and continue putting more points in if you didn't go far enough? You can. Okay, there's 1. Now, 3x plus y equals 5.
You just have to go for 3x.
Okay. To get y by itself, I have a positive 3x being hanging out with it. So if that 3x is added, we want to take the positive 3x and subtract. 3x's cancel. Okay. What do you know about 5 minus 3x? Yeah, if we keep the signs with it and just put it in the right order, it's a minus 3x, so that's going to be negative 3x. It's a positive 5, so plus 5. Okay. So, where do I start on this one? Y-intercept of 5. Which direction 5 am I going?
Positive.
Okay. Up 5. There we go. Up 5 is positive 5. Where do I go from this positive 5?
Over 3x minus 3x.
Okay, so my slope is negative 3. What is negative 3 as a fraction?
Negative 3 or 4.
Yeah. Put it over 1 to make it a fraction. So from this 5, I'm going to go down 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. Can I stop making points? I would. I would stop making points there. Okay, my line's not very straight up top, but that's why I have the dots, right? That's why I use, when I'm on paper, that's why I use a ruler. Okay. Got it? Are we done? You've done all the hard work.
You have to
Yeah.
be.
From the origin, where do you count to get to that intersection? Right 2, down 1. So 2, negative 1. Okay. I almost forgot, so I'm not looking at my paper copy of my notes. Okay, real quick, before I move on to the bottom problem there. Couple of special cases. If I give you the equation y equals 2, do you know how to graph that?
Yeah, sure.
You're supposed to, but do you remember, I guess?
Is it up and down? It's supposed to be up and down.
Do you want us to write that down?
Or yeah, as Lily says, horizontal.
I would encourage you to put this in your notes, because if I'm going to graph a couple of special case lines here, could they appear in your homework? Yes. And the words all, even horizontal vertical lines is what I'm talking about here. When there's only one variable, an x equals or a y equals, it's either horizontal or vertical. Now here's the problem. Do you know which is which?
I
Okay.
believe so.
So if it's y equals 2, it has to touch y at 2. So which one's our y-axis? Our y-axis is the vertical axis. So how do we touch y then? We're going to have a horizontal line
Touching all of two.
that cuts through when y is 2. So when you have y equals a number, this is a horizontal line. Okay, anytime it's y equals a number, it's a horizontal line.
So that means when it's X, it's going to be a vertical line.
Yep,
Alright.
you're still in my thunder, Kogan. That's all right. Okay, so the other option, if it's x equals a number, it's going to be a vertical line. Might as well go ahead and write in vertical at this point, huh? So if it's vertical, I'm going to say x equals 3. Okay, then that means on the x-axis, 1, 2, 3, you find where x is 3, and you, anytime x is 3, is going to be those numbers there, so it's a vertical line. We've already reviewed this year. This is not the first time of me going over this. However, is this maybe the time it will stick? You know, that's my hope, right? Is this the time it's going to stick, Levi? That's not good. Is this the time it's going to stick, Levi? Horizontal, vertical lines? Maybe it's already stuck for you, but sit up, please. Yes. Okay. We got the idea here, right? Your homework for the most part is going to be solving equations graphically. Y equals mx plus b form, graph them, and where do the two lines cross, right? At what point? Okay, I want to look at this word problem down here, and that'll pretty much take care of it. My morning class, there is a backside to the notes, but we're not doing them. My morning class ran out of time for it, and honestly, I decided that I'm just going to scratch that portion of the notes, and I've already adjusted the homework to work to take care of that. Okay, so I just have to do this next problem. Getting better here. Okay.
Not really.
Oh no.
Dang it. Is that because,
Recorded.
am I still, oh, I am still recording. Well, okay, so I can go back into my notes here. Open them with a PDF. Probably need to change that to always. Oh, hey. And it brought me right back to where I was.
Boom.
Okay,
Magic.
now let's try. I was trying to bring my dry erase thing back, and that's where what goofed me up. I'm gonna bring it over here this time. Okay. Is this thing gonna get out of my way? Okay, well, we will find out. Okay.
Did you get it?
Okay, we can see enough. You guys have this in your notes, right?
Yep.
Yes.
The growth of a Greenland shark is 7,500 centimeters per year, and its birth length is 37 centimeters. The growth rate of a spiny dogfish shark is 1.5 centimeters per year, and its birth length is 22 centimeters. If the growth rates remain the same, at what age would a spiny dogfish and a Greenland shark be the same length? Okay, that's what we're looking at there. Now, notice in this section it's talking about using a table to solve the problem. Okay, so it's not that we couldn't graph it. It's not that we couldn't use substitution, elimination, those type of things, but just using it, a table. So let's talk about what we know here. What do you know about a Greenland shark based on this problem here?
Well, from the freshwater.
Well, you know more than me, but I want to know about a Greenland shark according to this problem. What is this problem tell?
It is born at 37 centimeters.
Okay, starts at 37 centimeters. What else?
And then every year it grows 0.75 centimeters.
Okay, so after 1 year we add 0.75. After 2 years we add 0.75 twice, right? Or 0.75 times 2. After 3 years you add 0.75 times 3, right? Okay, so I'm going to set this up as an equation. And you can even just do an expression. But the idea of, okay, what did we just say? It starts at how long?
37.
37, and we're adding what?
0.75 per year.
0.75 per year. So what can we use as years?
Y.
I'm going to have to use x just because I already started with y equals. So, okay. So that's our Greenland. Now keep in mind, what did x represent? X was the age or the years. What is y going to represent then? If the equation equals y, what is y going to represent? If you take 37, you're adding 0.75, adding 0.75, what is that? That is the length, right? Okay, so that's what we know about a Greenland shark. According to this problem, notice how I phrased that. What do we know about a spiny dogfish shark? What do we know?
They start off at 22 centimeters and it increases 1.5 centimeters.
Okay, they start off to 22. They're increasing 1.5 centimeters per year. How many years? I'm going to say x right now, yeah? And you can just write that. You don't even have to have the y equals. You just have to have that part right there. So this is where I'm going to set up my table. And as I set up my table, I'm going to set up 3 columns. And the first part I'm going to have is the age, which age is what variable in my problem? That is the x. So that's the first column I'm going to have. Then I'm going to have a column for the Greenland shark and a column for the
Spiny dogfish.
spiny dogfish. Okay. For the Greenland shark, we already talked about the fact that we're going to be doing 37 plus 0.75x. And for the spiny dogfish, we already talked about the fact we're going to be doing 22 plus 1.5x. So with that in mind, how am I going to do this? What number should we start with for the age? Do we want to start with 1? How much work do you guys want to
I
do?
will say why. We know that's not going to be the answer.
Exactly. I'm not going to start with 1 because why do I know 1's not going to be the answer?
Because there wouldn't be an equation if it was.
Okay. I mean, here's the deal. At 0 years, at birth, they're 37 and 22. After just 1 year of growth, are they going to be the same? No. So it's kind of a guess and check process is what I'm using. You can start with 1 if you want. You can start with 0 if you want. But I'd rather jump up a little bit and not start at 1 or 2, real small number there. It's a random number of 7, but
So, why did I get it right on accident?
no. I was actually going to go bigger and suggest we start at 10.
Sure. You know what?
Just because I don't want to be here all day. And, oh, hey, I got about 3 minutes. I got to move. Okay, what do we do with the 10? You're going to take 10 and put it in for x, right? So grab those calculators. You're doing 0.75 times 10. So 7.5
Metric system.
plus 37. And we're at what? 44.5. Now, what should we also check while we're here? Spiny dogfish. So now I'm doing 22 plus 1.5 times 10. 1.5 times 10 is 15.
Plus 22 is 37.
Plus 22 is 37. Am I there?
No.
No. So we need to keep going, right?
No.
Okay. So, again, would you jump up to 11?
No, 15.
I wouldn't just jump up to 11 because are we closer? We're closer than we were at 37 and 22. But we're still pretty far apart, aren't we? So, the guess I heard was 15. So 37 plus 0.75 times 15. I don't remember that number.
48.25.
48.25, thank you. $22 plus 1.5 times 15. $44.5?
Yeah.
Are we closer?
Yeah.
Yeah, because if you look, right now 44 and 48 are only 4 apart. We were more like 7 apart earlier, right? We're getting closer. Now, how do I know I haven't gone too far?
Because one hasn't overcome the other.
Right, okay. The Greenland started longer, and so if all of a sudden he's not the longer one, we know we've gone too far because the spiny dogfish took him over. Okay? Okay, so keep guessing, right? What's another really good guess? 20 is a really good guess. So 37 plus 0.75 times 20. And I'm going to be at 52. 22 plus 0.75 times 20. And I'm going to be at 52. What did we just discover?
The correct answer.
At what age?
20.
20 years. Okay, the only part we did not get through is right here on part B, which is that, when are they 25 years old? How long will they be? Plug them in, okay?
So they wouldn't be even. You just get the answer.
Right, you're just getting the answer. Okay, your homework. Yes, you are to do the homework, which is, I will write it right here. Lesson 3.1 in Math Excel. Get it done for tomorrow. I am not doing any more notes on this. We did them all.
Yeah, probably. some
So
down
about
here.
the test, but
Good sense. It is. It's good. Try and find